And that's where we're going to look at logarithms. Okay, the logarithms we've actually already done, because if you've done exponents, you've done logs. The rules that apply to exponents are the rules that apply to logs. And basically, if I have an exponent, 2 to the power x equals 8, my input is 3, I do my exponent, and my output is 8. All the logarithm is going to do then is going to go in the reverse direction. Okay, so I'm going to give my output, my answer is 8, and I want to figure out what my exponent is when I have base 2. Okay, and that's essentially what a log is. It's just going the other way. So we've actually done this already, because most of you probably would have figured, oh, I know the answer is, if I were given this equation, you know, the input should have been 3. Well, that would have been my output if I expressed it in terms of logs. So logs is just the opposite way of expressing exponents formally. Okay, we've already done logs. If you've done exponents, you've done logs. But now we're going to express this formally, write it formally using a logarithm. So the way we write it formally using logarithms is this. We are going to take this exponential expression here and convert it to log by doing this. We write a log. Okay, the log indicates that you're undoing an exponent. And the way we write a log is we keep the base the same. So if it's base a here, the log base has to be base a, has to be. And the answer to the log is an exponent. So x is our exponent here. So that matches here. And this is what we call an argument. What we put inside the log with an input to the log is the answer to the exponent. Okay, and all we need to do is be able to, there's no calculation involved other than what we've already been doing. We will introduce our calculator at some point where when we have problems with non-common bases like we did with that 5x to equals 100 problem. That's when we need calculators. Okay, this one here. But we need to understand how to write a log first. Okay, so what we want to do is then, again reiterating this, the base of your exponent is the base of the log. The log answers the question, what's the exponent? So that must be equal to the exponent. Okay? And the log allows you to calculate this exponent, so the input should be your answer to the exponential, the output should be your exponent. So we're just going to work on writing this as a log. Okay, so 10 to the power 2 equals 100. That's perfectly true. But we want to be able to convert this exponential expression into a log expression. So that's all we're doing right now. So I'm going to start here. So I'm going to write my log. Okay, so log. Where do the different parts go? Well, the base of my exponent has to be the base of my log. My log always equals the exponent. Okay, because the log is the output for log is your exponent. And then the last part here, the output of the exponent is the input of my log. Okay, and if you want, some of you may want to right now explore your calculator, and there should be a base 10 button, log button on your calculator. And we do logs with every base, but the calculator only has certain bases built into it, and base 10 should be one of them. You might want to try it. Go log 100, so your input's 100, you should end up with an exponent of 2. So we'll do the same thing here. Write the log. Okay, the base of the log is the base exponent. Okay? If it's a base, it's a base, it's a base. My log, the output, or what the log equals, is always the exponent. And then the input is going to be what we call an argument, and that's what came out of the exponent. Okay, so this one here, we're going to again write our log. The base is the base. There's my base. Okay, so I need to write this as base 10. The log always the answer to log, or the output of log, is my exponent. Okay? The input is what we call the argument, and the argument is the output. The output of the exponent is the input of log. Okay? Looking at this one here, same thing. Log. Now we're not doing base 10. Okay, so most of your a lot of your calculators don't have a base 3. Okay, so this one may not be able to be done on your calculator. 3, the base is 3. It equals 4 because it always equals, the output is your exponent, and the input should be your argument, or the answer to the exponent. Okay, so if your calculators can do this, you might want to try that. Go log base 3 of 81. You should get an exponent of 4 when you do this. But again, this is not about the calculator, about calculating things. We want to understand how the log and exponent algebra now works. So we're going to do a lot of this is going to be done with variables. Okay, so here's my log again. My exponent, my base has to match. Okay, base is a base. My argument always equals, my log always equals, the answer is the exponent. Okay, and we're inputting the output of the exponent. Okay, that's called the argument. Okay, so this is the main idea right now. We've actually already been doing logs. We just want to now formally do it, so we have to be able to express an exponential expression as a log expression. That's what we want to focus on right now.